Okay, good afternoon. My name is Frank Slazer. I'm the president and CEO of the Coalition for Deep Space Exploration. Coalition is an industry trade association representing about 50 firms from around the nation of various sizes, focused on industry issues, space exploration, space science, and space technology development. Our membership includes the most diverse range of companies in the space industry, from established aerospace primes and newer commercial space entrants to a variety of small companies in the space industrial base. And about 46% of our member companies are small businesses, and nearly 10% are composed of women-owned or veteran-owned businesses. This is the seventh episode of our Space 101 educational webinar series, where we try to bring space experts together from industry and government to educate and help educate the media and answer questions on how space missions are accomplished, what goes into space system design, and what is the science behind what we do. This webinar will be archived on our website along with our earlier episodes and is available for you for subsequent viewing, or if you want to refer this content to your colleagues. Today's episode will discuss NASA's plan for the Lunar Gateway, and we'll look at what goes into assuring that what goes into the decision to come up with this unique approach to lunar exploration and what the benefits are, as well as some of our international participation. And it's a vital part of NASA's Artemis human space exploration program. Our moderator is Dylan Connell. He's at NASA's Johnson Space Center, and he's in their communications office. Dylan, over to you.
All right, thank you, Frank. Good afternoon, everyone, and thank you for joining us today. As always, it's a pleasure to see so many familiar names who regularly cover NASA. So as always, we sincerely appreciate your interest. As Frank said, my name is Dylan Connell. I am the Public Affairs Officer for NASA's Gateway program, and I will be moderating today's session, starting with some introductions of our speakers. Sean Fuller is NASA's International Partner Manager for Gateway. He has over 22 years of experience working in and leading human spaceflight teams at NASA and international partner teams in Europe, Russia, and Japan. Sean's extensive experience supporting ISS includes recently leading the human spaceflight transition study team, working with ISS partners to advance goals in exploration, leading to cooperation on Gateway. Sean earned his bachelor's degree in engineering physics from Embry-Riddle Aeronautical University. Sally Richardson is Northrop Grumman's program director for NASA's Habitation and Logistics Outpost, or HALO program. Previously, she was Northrop Grumman's program manager for the Human Landing System under the national team, and prior to that, Northrop Grumman's program manager for the Power and Propulsion Element studies. In her career, Sally has worked on a variety of satellites, launch vehicles, and other aerospace projects, and has worked at Northrop Grumman for the past 29 years. Robert Curbeam is a former NASA astronaut and naval officer and a graduate of the U.S. Navy Test Pilot School and Top Gun. He has flown in space 3 times, logging over 900 hours, 45 of which were spent doing 7 spacewalks to build the International Space Station. Robert's currently Senior Vice President of Space Capture at Maxar, where he leads business development for the company's civil, national security, and commercial space portfolios. So thank you to all 3 of our speakers for being here today. We're going to start out with an overview of the Gateway program from Sean, followed by a HALO overview from Sally, and an overview of Gateway's Power and Propulsion Element, or PPE, from Robert. Following that, I'm going to moderate a bit of a discussion amongst our speakers, and then we will take some questions from our audience. So with that, thank you all again for being here, and I will pass it over to Sean Fuller.
Well, thanks, Dylan, and thank you to the Coalition for Deep Space Exploration for hosting us today. It's great to come talk to you, talk about Gateway, where we're at, and looking ahead to the future. I'll reflect on the apropos opportunity celebrating the 64th anniversary of NASA today, and then looking ahead at where we're carrying in the future as well. As Dylan mentioned, we're here today to talk to you about Gateway, what we've done since the beginning of the program, which is just a short 3.5 years ago. Been making a lot of tremendous progress as we develop Gateway, our plans for the future, and putting those together to enable lunar exploration with an eye out to the future and stepping off onto Mars. In that past 3.5 years since the beginning of the Gateway program, we have made a lot of progress. We have contracts in place on the U.S. side that you'll hear about for our first elements, the HALO PPE, as well as the rocket to launch those. and our logistics vehicle to provide some early logistics for Gateway as well. A lot of hardware being built around the world for it, and I'd be happy to go through those details with you. Also, a key component of Gateway is its international capabilities and really an international hub for Artemis. We have agreements between the U.S. government and our colleagues at the Canadian Space Agency, the European Space Agency, and also in Japan for key components of Gateway that really enhance our capabilities, round it out, and enable this future endeavor with NASA leading us into the future with that experience, building off of our 24 plus years of ISS, 22 years of crewed presence later this year on ISS. So we're taking that partnership, we're going into deep space and taking steps further. And so let's see if we can go to the next chart, Dylan. We'll go into a bit more detail on it. I mentioned a Gateway. It's going to be an outpost, obviously, around the moon, but it's going to enable us to do so much more. In our unique orbit around the moon, it will give us access to certainly the South Pole regions that are of very much interest to us, and a lot has been learned, obviously, about the lunar surface, and particularly the permanently shadowed regions in the South Pole. It'll allow us to have cruise access there, but also in its north-south polar orbit, could give us access to anywhere on the moon. So really, if you look at Gateway, it's that door that's opening us to lunar exploration. We'll be developing technologies on there, capabilities that will also lead us forward to Mars as well. So really a key piece of that moon to Mars exploration architecture. It is a human tendon, and so what that means is we'll have crews there really anywhere from 30 to 60 days, kind of limited by logistics. So additional logistics will allow us to bring more. But also times when crews are obviously not there. That doesn't mean that the work on Gateway stops during that time frame. We'll have science and utilization from the very beginning with the launch of the first vehicle, which we'll talk about in a little bit, but then continuing that science while the crew's there and while the crew is not there. This gives us a new, unique platform in its orbit around the moon, a different perspective of the Earth-Moon system with that platform. And so we'll be able to do a lot of really fascinating research there, particularly in the radiation realm, getting outside the Van Allen belts, and the opportunity to do the science and research in the Gateway platform as well. Obviously, some differences from ISS. We're about a fifth of the size of ISS if you look at the volume, not crewed all the time, and so we have some features of that's baked into the system as we look at that reliability and the autonomy without the crew there all the time. And in capability, we plan for 15 years, but like I said earlier, we're now in the 24th year of 15 years of ISS and many more to go ahead. I could certainly foresee the same for Gateway as we look into the future as well. Kind of running down some of the pieces to it. I mentioned that this is our international hub, and it's our partners helping us go forward. And so some of those early components on that first element that we launch is going to have a European system, a Halo lunar comm system that'll enable us to relay from the lunar surface back to Earth, both the audio as well as some of that great imagery we're going to get with the crews on the surface as well. That'll be on that first launch, and then after that will be a European developed IHAB module, International Habitat, along with our Japanese colleagues building the life support system and some of the thermal components within there. That really expands our capability. The crew quarters CO2 scrubbing, so we're not reliant on LIO. CO2 scrubbing expands that opportunity for longer duration missions at Gateway. Beyond that, we have what's called the Esprit, the European system, providing a refueling module that'll provide refueling to the PPE, both chemical propellant as well as xenon for that system, and the beautiful windows that the crews will be able to look out and see the lunar surface and back to the Earth as well. I know I'm looking forward to some great pictures from there. Other components, the Gateway robotics system, by our Canadian colleagues, affectionately called Canadarm3, that third evolution from Canadarm1 on the shuttle, Canadarm2 that's working for us so wonderfully today on ISS, and in Canadarm3. And really, if we look at many components of Gateway overall, you see an evolution building on that ISS heritage to take us as a step forward. Canadarm3 is certainly a glowing example of that for us. Other components coming out in the future, I mentioned a logistics module that'll provide us, obviously, the logistics. First contract has been awarded to SpaceX with opportunities in the future for additional logistics modules. We have the opportunity to on-ramp, as we call it, future logistics providers. Also, our Japanese colleagues will be providing HTV-XG, that's HTV-X for Gateway. Next year, they'll be looking to fly the first HTV-X, which is a next generation resupply spacecraft to ISS. Again, we'll take that, we'll evolve the capabilities there for us in deep space and have that in our suite of vehicles to resupply Gateway and support us for the Artemis missions. And then the final component of Gateway will be an airlock. I'll tell you that we're in negotiations with a potential new provider, new partner to join NASA with us on Gateway, and look forward to having that both crew and science airlock for us here at the last assembly flight, if you will, for Gateway. We'll talk in a bit about the first launch on SpaceX, the future launches for IHAB, Esprit, and any airlock module. Those will be co-manifested along with Orion on an SLS launch. So really rounding out that capability, the Block 1B, the exploration upper stage of SLS will be providing to the Artemis campaign with its first flight of Artemis 4. That'll fly IHAB, and then we'll have Esprit and the airlock on flights after that. So just kind of a real quick overview from the top. I'll look forward to your questions here coming up, but let me hand it over to Sally to talk about the first elements and Robert, and we'll get into those details.
Thank you, Sean, and thank you to the Coalition for inviting me to speak today, and also to the media who's present. Looking forward to answering your questions. So Northrop Grumman has partnered with NASA over the last 50 years on several high-profile missions, and of course, most recently, the very successful James Webb Space Telescope, where we've just seen some of the most spectacular images in the last couple of weeks. And Northrop Grumman is continuing to partner with NASA in their goal of returning to the moon and exploring deep space and Mars. So in addition to HALO, which I'm going to talk about in a few minutes, Northrop is also involved in providing the solid rocket boosters for the NASA Space Launch System, as well as the abort motor and attitude control motors for the launch abort system on Orion. But today we're focusing on HALO. So if I can start with that. So as the name implies, HALO provides habitation. So we're providing a comfortable and habitable living space for crew, up to 4 crew, as they prepare for their sorties to and from the lunar surface. We also have provision for exercise equipment, and I don't know if you can actually see it here in the cutout on the lower right, but we do have an exercise bay. We host a variety of payloads. We support the robotic interfaces that Sean just referenced that are coming from the Canadian Space Agency. We provide high voltage power transfer. We provide thermal control, as well as all the environmental control and life support systems for the crew for 30 days, or up to 30 days. So HALO, as was mentioned, is kind of serving as that gateway hub in amongst all of the various modules that will be docked to it. So we have 3 docking ports. They will be used primarily for the visiting vehicles, such as Orion, the logistics modules, and the human landing system. But in the not too distant future, we are expecting one of these ports will be permanently used to grow the gateway. So the international habitat, which ESA is developing, will permanently be housed at the front end of the HALO module. And that will expand the living quarters for the astronauts and will provide the additional crew resources for extended missions beyond the 30 days. We also provide, we host the European Lunar Communication System that Sean mentioned, and we also facilitate the transfer of fuel. So we are involved in the refueling of the Power Propulsion Element that you're going to hear more about from Bob. Next slide, please. So we've made a lot of great progress on HALO. We've been able to leverage a lot of the heritage from our human-rated Cygnus vehicle, which last month completed its 17th commercial resupply mission to the International Space Station. We've been able to leverage a lot of those design features in Cygnus, such as the pressurized module, which you'll see in a couple of pictures that is being developed at our partner in Turin, TASI. We've also been able to leverage a lot of the fault management and the computer-based control systems, as well as a lot of the integration and test procedures and processes, given the similarity in the design with Cygnus. And you know, this heritage really has enabled us to get a jump start on the development of HALO, and I think, you know, we are where we are because of that experience and that heritage base. Next slide. So in 2020, NASA decided to launch both the Power and Propulsion Element as well as HALO on a single commercial launch vehicle in what is called the co-manifested vehicle, CMV. These two modules will be integrated on the ground. They'll be launched together on a HALO Falcon Heavy rocket. And one of the advantages of co-manifesting the two vehicles is that it really does reduce the risk of having to perform an in-orbit docking, and therefore it will enhance the mission success. Northrop Grumman has been chartered with providing the systems integration of those two modules, and we are heavily involved with our partner, with Maxar, working preparations for that launch. Next slide. So this shows really the progress that we've made to date. We had our PDR last year, and we just about to have our system CDR next week, which will be the culmination of a whole series of subsystem CDRs that will result in a clearance to move out on all of the flight fabrication and move forward. Having said that, we do have a lot of flight materials, flight development that's already taken place. Again, because of the heritage associated with Cygnus, we were able to make great progress. So we have, as you can see in these pictures, these are all pictures that were taken at our partner, TASI Teleselenia Space in Turin, Italy. And you can see, you know, we've gone from forgings back a year and a half ago to on the right-hand side here where it says longitudinal welds complete. This is the first section of a 3-barreled section that has just recently been completed, and the second barrel of this module is currently underway. I've included in the lower right here a mock-up of the HALO module, and I included that because I wanted to speak to the fact that we are using a lot of the crew interaction with our design to inform our design. So we've done up until now, we've been using virtual reality, and we've conducted a variety of human in the loop tests to really feed back into the design so that we are truly accommodating the crew needs and providing that the provisions for their stays in at Gateway. The mock-up that you see in the lower right, this was an early picture taken at the beginning of the year. That has evolved significantly since that picture. I've included it though. It's got yours truly in here, along with the NASA program manager, John Alanson. And we were doing a little bit of our own human in the loop testing in this picture. So next slide, please. So with that, I'd just like to summarize by saying that, you know, HALO will be providing a lot of you know, really unique technologies associated with living in a very extreme environment in cislunar space. So we have the life support, the avionics, the thermal control for up to a 15-year life. But we also have the provisions and the hooks in the design to extend that life, with the ability to do upgrades, maintenance, and parts replacement on subsequent missions. So, you know, we are confident that that 15-year life could be extended to match, you know, lifetimes such as the ISS, as Sean mentioned. And so, you know, we have that maintainability as a key requirement in our design. I think the final takeaway here is that, you know, we don't forget who we're working for. We are focused in every aspect of our design on ensuring crew safety and comfort during these lunar sorties. The crew will be very, very far from home, and our design is intended to provide all of the functionality that they need in that gateway hub as they transition to and from the moon. So with that, I'd like to pass it on to Bob. Thank you.
Thanks, Sally. I appreciate it. If you could go to my first slide, thank you. I'm going to talk a little bit about the power and propulsion element, which is truly the foundational element of Gateway. It provides the power, maneuvering, attitude control, and communications for not only the co-manifested vehicle, but the entire Gateway space station in lunar orbit. And we're really, really excited about providing this because this PPE will actually allow us to maneuver and control the station to allow access to any point on the lunar surface. And that's new. And this is really important because this is a natural evolution of exploration of the lunar surface. Before, when we went, it was kind of like a backpacking trip. This is a sustainable presence in cislunar that allows the astronauts to go down and visit any point on the lunar surface, and also can be used as a gateway to other deep space destinations. So it's really, really important that it's a reliable and sustainable platform. And to that end, we've actually based this design on our 1300 bus, which has many, many years and years of flight time in GEO. And we've basically taken that design and expanded it to meet the needs of the station. This design will be the most powerful electric propulsion spacecraft ever when it launches, with a total of 7 different EP thrusters powered by those 2 very large solar arrays that you see in the picture. And it'll be providing over 60 kilowatts of power when it's up there, which is amazing because the 1300 bus from which it is derived, this design is derived, maxes out at about half of that. So this is truly a tremendous leap in capability for our 1300 bus, and will provide the astronauts with the power they need to live, operate, and work in deep space. And this truly allows us not only to be a leader in space, but also cooperate with our international partners to make sure that when we return to the lunar surface and we live in this lunar space, that that we go there as a human race and not just as a country like we did last time. And because this system is derived from our 1300 bus, it's a very reliable platform, and it'll be very sustainable in that we built it to be refueled, as Sally talked about, and that will allow us to keep this platform in cislunar space for years and years to come. At Maxar, we're very, very proud to be able to provide this service module, or PPE, to Gateway. And Maxar is really in a sweet spot as far as company size is. We're large enough to have really good reach back and lots of engineering support for development of this PPE, but also small enough to be agile and respond to our customers like NASA and the ultimate customer, which we the astronauts, who live and work at Gateway. I also wanted to show one other picture of our solar electric propulsion thruster actually going through its test at NASA Glenn in a vacuum, which will be the centerpiece of the capability that we provide to this international gateway station around the moon. And with that, I will pass it back to Sean.
All right, well, thank you, Robert and Sally and Sean. At this time, I would invite those in the audience, if you have any questions for our speakers, we will get to them in just a few minutes. But if you'd like to put those questions into the chat, we will take them on a first come, first served basis. While folks are adding their questions, I would love to have a conversation with our speakers with just to discuss a few things. My first question is going to be for Sean. Sean, could you please expand upon why the international partnerships are so important for a platform like Gateway?
Yeah, thanks, Dylan. You know, the international partnership really is at the core of Gateway and kind of building it off of ISS. I mentioned before, you know, we've had ISS in orbit for a few decades now, but that was really building off of some of our partnerships before in the shuttle program, or going back even farther than that. What we've seen and what we've experienced on ISS as well is when we bring these partnerships together, you know, we as a coalition, if you will, are exploring space. We're each bringing our capabilities to that. And of course, as we bring those together, we can do so much more in that investment. If we look at the overall Artemis campaign, it's going to take quite a bit to launch, to get the crews on the lunar surface, to develop technologies, and then to go on to Mars. And so we're doing that by leveraging off of our partners and them leveraging off of us and our capabilities. Not only do we have Gateway, there's the Artemis Accords as well, where NASA is really leading that coalition of exploration around the world. 21 countries now have joined together and said, this is what we want to do and moving forward. This is how we foresee space exploration and how we can partner together, leveraging those resources, achieving that common goal, and really, as Robert said, for the benefit of humanity as we look at that. And so I think you can see a lot of great benefits from it. From a U.S., obviously, what that means is our tax dollar goes even further because we have our partner agencies and partner countries participating in it as well. As you look at Gateway, at some of those great capabilities that round out Gateway, while we extend our resources from NASA onto lunar surface and onto Mars as well.
Awesome, thank you, Sean. My next question I will pose to Sally. Sally, could you please talk about how HALO is being built differently than the habitation modules you would see on the International Space Station?
Certainly, Dylan. So yes, one of the key differences, obvious differences, is size. So as Sean mentioned, Gateway itself, even when we're fully developed, will be a fifth the size of the ISS. And recognizing the fact that we have to launch mass all the way out to the cislunar space, everything is essentially scaled down. So size is one difference. The other major difference is the location. So the environments that we will see in cislunar space are much more challenging and harsh than they are in our low Earth orbit. And so we have to design for that, and we have to test for that. The other difference is that we have crew visiting on their way to the lunar surface. And so for very large periods of time, the HALO module will be uncrewed. And so we have a lot of autonomous functions and features that we have to design into HALO so that when the crew are visiting and available, we are very quickly able to reconstitute the services to be crew compatible. And then, of course, we do have a 15-year design life, but as I mentioned, we will be doing maintenance and upgrading those capabilities with subsequent missions. But those logistics missions will be less frequent than they are to LEO, and so therefore, we are constrained in the ability to be able to make those upgrades. And then I guess finally, it's not so much a difference, but while we are definitely supporting science and research, the science and the research will be different in the location that we're at. So we are hosting payloads that are provided by our international partners and by NASA that will be characterizing the environment primarily in the near term, and then ultimately doing a lot of experiments that would be targeted towards deep space exploration, human exploration. So I guess they're the primary differences that I see.
Thank you, Sally. And then our last question before we move to some questions in the chat box, I'd like to pose to Robert. to discuss just the importance of leveraging existing technologies for platforms like Gateway, or really many aspects of the Artemis programs. Could you speak to the importance of commercial technology?
Well, I think probably the most important aspect of that is the fact that commercial technology allows us an opportunity to reduce the development time that we need to produce these new systems. There's two things that are very, very important in our commercial technology that we use, especially in our 1300 bus, and that is reliability, sustainability. And because we have so much heritage flight time in GEO on these systems that we're incorporating now in PPE, we understand the characteristics of their operation and how to make sure that they're reliable and sustainable. And so what this does is this reduces the amount of development time, ensures a better schedule, and reduces cost in building the new systems that we will need to produce to go into deep space.
Got it. Thank you, Robert. And actually, before we go to questions in the chat box, I had another question for Sean. Sean, could you talk about more specifically Gateway's role in paving the way to Mars?
Yeah, certainly, Dylan. Thank you. And as we mentioned, Gateway is taking that next step. So we're outside of LEO, and as Sally had talked about, the different unique challenges out there. Gateway is going to give that platform. We have landers that go to the lunar surface. We're going to develop some technologies. The autonomy part of it actually is going to be very important, the reliability in the systems. When we go to Mars, we're not going to have the luxury like on ISS today, where you have a resupply mission about once a month that you can spare. You can bring up new hardware. You can bring hardware home to do failure analysis. So Gateway is going to expand that, but also the capability is a stepping off point. So we build Gateway. It's modular, very similar to ISS. If you look at the graphic I had, it has docking ports. One of the things that we have in our capabilities is to add future growth. And so, for example, things that we look at is a Mars transport type spacecraft that could come to Gateway, initially have its activities at Gateway, outfit the module, get it up, test it out, make sure it's ready, and then do a design reference mission in perhaps a lunar orbit. Really a shakedown type cruise. So it would separate from Gateway, do a shakedown type cruise, come back to Gateway. That's where your crewed vehicles could come, Orion come to bring crew and bring them home. And then once that all is complete, you have the opportunity again. You've got the infrastructure there in lunar orbit. So you've done all your energy to get off the Earth, assembled it in lunar orbit, and now go off to Mars. And so Gateway really opens that door and can provide that opportunity for that, not only in tech development, but then as a place to step off from for the future.
Very exciting. So Gateway, we expect to have a long lifespan supporting various missions. Okay, well, with that, I think we can start taking some questions from the audience. Our first one comes from Richard with the Orlando Sentinel, who is interested in knowing when we will see the first human presence on Gateway. Maybe a good question for Sean.
Yeah, thanks. So we launch the CMV. It'll spend about a year to get out into lunar orbit. So really, at that point in time, Gateway as a vehicle is ready to accept crews. We couple it with Orion's life support capabilities, so we're somewhat limited in the duration there, but certainly can have crews there at that time frame. When we add the IHAB module and that carbon dioxide scrubbing, additional crew quarter capability, additional life support systems, you can handle longer duration crew stays. So I would tell you from the time we launch that co-manifested vehicle, about a year's worth to get out there, then the system of Gateway, if you will, is ready to accept crews. Obviously, we're looking at the human lander system, its first planned launch on Artemis, that flight to the lunar surface, follow-on missions through Gateway a little bit later. So that's planned with the Artemis 4 mission, looking around the 2027 timeframe. But I tell you from a capability of the vehicle, it can be ready before then. It's a tool in our architecture as we plan the Artemis manifest.
All right, thank you, Sean. Our next question comes from Marcia Smith at Space Policy Online, and I think I'll pose this question to Sally and Robert for either one of you who'd like to answer, or maybe both of you. Could you speak to the nature of the partnerships with the commercial companies? Who owns Halo? Who owns PPE? Or is NASA just purchasing services?
So I can start with that, Bob. So yes, NASA will own the hardware. We will do a traditional development program and then deliver the hardware to NASA with a DD-250. And I believe Bob is in the same situation.
Exactly. Yeah, we are delivering hardware to the agency. They will own and operate it.
Got it. Thanks, guys. And actually, kind of in a similar realm of talking about commercial partnerships, wanted to pose a question about how both Northrop Grumman and Maxar are working with additional private companies as subcontractors on the modules that you're building. Could you characterize who you're working with and what they're providing?
Oh gosh, I mean, the list of suppliers that we have to build a spacecraft are enormous, and so I don't want to name any specific ones for the fear of leaving somebody out, which I'd have to do. But yeah, they're enormous, they're international, they're global. So I would say, the list is in the hundreds as far as, when you look at all the piece parts that we have to buy and all the ground test equipment that we have to provide to actually make sure it's ready to go. So I wouldn't take the chance of just leaving somebody out, which I'd have to do if I named all of them.
Copy.
And I have a similar answer. We have a very large team of government, international, commercial partners and suppliers. I mentioned Tassie by name, who is developing our pressure vessel and our primary structure. We do have other European suppliers. Airbus CRISA in Spain is building our power management and distribution system. TT Tech in Austria is developing our advanced avionics. And Collins Aerospace is developing our advanced thermal control system. And Paragon is providing our environmental control and life support system. And I mention them by name because they are really the primary suppliers. But as Bob mentioned, we have tens of other suppliers. Many of them were suppliers on CRS, so we have a lot of history with those suppliers. And some of the relationships that we are using on the Halo program were previously established on CRS.
And that's a great point that Sally makes, because these systems, these two modules are actually derived from commercial systems. We have very well established relationships with most of our suppliers. And this is an extension of that relationship, not a new relationship.
All right, thanks, guys. A question for Sean. Could you characterize the state of the airlock for Gateway, please?
Yeah, certainly. So as you see, airlock is one of the key components. We've been doing some work within NASA to define those requirements for it, to kind of get a bit of a running start, if you will, in terms of the technical requirements. It, by the way, will integrate with the new suits that we have on the XEVAS contract that NASA recently awarded. We're in the process, like I mentioned, of some of the first steps of negotiating with a potential future NASA partner. Very positive. I would tell you, I expect and anticipate that to hopefully close out before the end of this year. I'm never surprised what we can do in terms of working the technical aspects of it, but then there's also the governmental aspects of agreements as well. But I would expect to get that closed out by the end of this year. I'll tell you, as you look at the schedule ahead, I mentioned our sequence of assembly flights, if you will, for Gateway. Airlock is the last flight in there. Critically important for that capability, but it's a last module in our Gateway buildup. And so that we have that runway in front of us. So having an agreement towards the end of this year, perhaps early next year, certainly plenty of runway in front of us. Again, I see this as building off a lot of heritage as well. If you look across the Gateway, you see some of that heritage, which helps us, as Bob and Sally have talked about in terms of timing. I could foresee similar things happening on airlock as well as we look around the world. And so that'll really help us in that timing. So again, I'd look at it in about 6 or 7 months, but plenty of runway in front of us, and looking forward to having that piece firmed up for Gateway also.
Thank you, Sean. All right, folks. If anyone has any additional questions, we welcome you to add them to the chat. I've just added some links to some various resources for anyone who would like to do some follow-up research on Gateway. So if nothing else, we'll go to our last question, another one from Marcia Smith, and I'll pose this to Sean. If you could please characterize the sequence of launches for the Gateway vehicle, starting with PP and Halo, what's going when and on what vehicles. And before I let you answer, Sean, I will say to Marcia and everyone on the line, our Gateway buildup animation that I just linked to will show you much of this, but I'll go ahead and let Sean answer.
Okay, certainly. Thank you, Dylan. Right, so the first launch, the co-manifested vehicle, that's a Falcon Heavy with an extended fairing. So that'll be the first one. After that, the next element is called the IHAB, ESA's International Habitat. That will be launched with Artemis 4, and so that'll be the first EUS or Block 1B SLS flight. Launch Orion and then a 10 metric ton IHAB. Orion, once you get into orbit, into high Earth orbit, it will undock and then come around and dock to IHAB and then tug it out after the EUS performs a TLI, tug it out to Gateway or to PP and Halo at that time. So that'll be the next flight. Somewhere in there, and we're working through the timing, a logistics flight either associated with that flight on Artemis 4 or before the next flight on Artemis 5 will provide the first logistics vehicle. I will tell you that the logistics vehicle for Artemis 5 will include the Canadian arm. And so very similar to how we had on a shuttle flight where we launch the arm in a payload bay in a cargo configuration. In this case, it'll be launched in a cargo configuration with a logistics module, walk off from that logistics module onto Gateway and be ready for the next element, the Esprit refueling module, which will launch again in a co-manifested, so on SLS with Orion as a tug on Artemis 5. And so then that provides our refueling capability, additional stowage, those windows that I talked about. And then the next flight next crewed flight, which will have a logistics flight. At that point, every flight will have logistics providing those capabilities for the crew, your normal consumables, scientific research for the mission, capabilities that we need in terms of logistics to support the other missions from Gateway, perhaps lunar surface, depending on what comes with those landers. So we'll have a logistics flight with each one, but then that Artemis 6 flight will also be a co-manifested payload with the airlock. And so after CMV, each of those major elements, with the exception of the arm and its logistics flight, those are flying as co-manifested payloads with SLS, Block 1B, and Orion as a tug that will tug it out to Gateway and then dock the module with Gateway, and then obviously Orion departs as itself.
Thank you, Sean. So we're not seeing any more questions in the chat. So thank you to those who did send us questions. I will pass it back to Frank to close us out for today's session.
Thank you, Dylan, and thank you for all our participants here today on the line who answered questions. This is the 7th of our series, so we planned on having a number of these prior to the Artemis 1 launch, which is now scheduled for August 29th, as you no doubt know. Our next Space 101, which is going to be our last of calendar 2022, is going to be held on August 12th at 1:30 p.m. And it's going to answer a question that was received from a participant in an earlier session: what goes into determining a launch window for space missions? And there's a lot of things that go into it besides orbital mechanics, although that's certainly part of it. And with the launch of Artemis 1, this could be very helpful if you wind up happening to explain why the launch has slipped and how the slip is determined to a specific date in the future, because it won't necessarily be the next day. Actually, NASA's already said that if it doesn't happen on the 29th, the next dates are the 3rd and the 5th of August. So I'd encourage you to join in and join us for that. If you are interested in attending, please email Jamil Castillo, who's the support staff person here at CDSC for this. And also, if you could let us know your views on the series, whether you've got questions in the future you'd like us to address next year, or topics you think that would be helpful. And also, if you just have some feedback, was this helpful to you in your professional work that you're doing, and any other topics you might think we should consider for next year. So thank you all for attending this and for the series so far. And again, thank you for the panelists, and have a great weekend.
Thank you.